Hello, Mr. Ray, Mr. Ryan, right?
Yeah.
So we have to talk about this grid on day 99, right? We have a grid. Yeah, we want to.
The grid.
Yeah, a grid of grid.
Grid.
For example, that's the star. That's the destination target. And if we are here, we can walk east and south.
Yeah.
At each step, we can only walk to the right or walk to the south, okay? So, and we want to calculate the number of the ways.
To the east and walk to the south.
That's right, east, south, right? And we want to calculate the number of ways reaching this point, right? Let's say FRC.
But this
Rows,
was on
columns.
This was on day 99.
Yeah, I know. FRC is the number of ways by walking from the top left to the current position. If we are here at this point, what is the previous step? Here and here, right? So this is RC, right? FRC. And this place is FR minus 1C. This place is FRC minus 1. So it equals FR minus 1C plus FRC minus 1, right? Dynamic programming equation. And then with this equation, we can use the minimization. Top down, bottom up, right? Top down, define FRC. What's the terminal condition? How do we solve this the basic scenarios? At the first column, what's the number of ways? At this first row and first columns, what's the answer? How many ways to reaching the any points here? How many ways reaching here? How do you get here?
You just go there. One.
Yeah, just one way, right? Yeah, because if I any points on the first column or first row,
Go right. You can't go
you
left.
can. There's only one way, right? So if R equal 0 or C equal 0, then return 1, right? Otherwise, return this thing, right? But what's the problem with this one? What's cache? Where down cache? Because if you're not putting the cache, what will happen? So look, for example,
You
here.
can't remember if it's dead.
That's right. If I need this value, so it might need this value here. It might need this value here. It might need this value here. It might need this value. Okay? There are lots of ways, right? Lots of ways needing this value so many times. So for each time, I have to calculate again, and then that's going to take exponential time. With this cache, we're just saying that for any grid, any cell in this grid, we're just calculating once, right? Because how many cells are there? R times C, right? For these R times C cells, I only calculate the value once, okay? This is top down, using the cache. And we're using the bottom up as well, right? So we can calculate the value here, and we can add it up, accumulate, okay? I want to calculate the probability, another probability. What's probability?
It's so like percentage.
Percentage probability. The value is from 0 to 100, right? Percent. Okay, so let's take a smaller grid, for example. Smaller grid. So let's say going to the right, 50%. Going to the south, 50%. And I want to calculate the probability of
East and south. East and south.
east and south, 50%. Now let's just consider 50%, okay? 0.5. So I want to calculate the probability of reaching this point. Okay, so without calculation, what's the probability of reaching this point? If we go from top left to the bottom right, what's the probability without calculation? Start from top left to the corner right. What's the probability of reaching this point? Okay, so previously, we're talking about the number of ways, right, of reaching this point, right? We calculate the number, that's total number, total paths, right? This is FRC. What's the probability? We calculate this point, FRC, different RC divided by T. This is the probability, right? So without a calculation, what's the probability of reaching this point?
100%. 100.
100%, yeah. Because no matter what, you will reach this point. You go from left to the right. You keep going, you will reach this point. 100%. Right? That's what I'm saying. Here is 100%. Okay. So what's the probability of here? What's the probability of this?
100%.
No? Why is that? I can go down.
50%.
50%. Yes. So this is 1. This is half. This is half. What's the probability of here?
Is it like 25? A quarter?
A quarter. Well done. Right? Because this times every time
25%.
split into 2. So it's a quarter, okay? So what's the probability of this one?
Half.
Half? How? Well, how do you get a half? We take this value, right? Half of percent will go here, right? We take this value, right? 50% will go there, right? Add it up together. So what's this value?
That's half.
Okay, half. Okay. What's the probability here? The same, right? We take this value
Yeah.
times half, 50%, plus this value times half, okay? Which is
3/8.
3/8, yes, 3/8.
Maybe.
Yeah, okay. What's the probability here?
Quarter.
What's the probability here? I will get this, half times half plus quarter times half, which is the same as this one, right? Is it?
Yeah. 3/8.
3/8. This should be 1. What's the error?
Maybe the 3/8 part.
What?
Maybe you're not supposed to do the 1/2 and 1/4 to get the 3/8.
Okay, that's the problem.
Because we're already with value. You only can go down.
Yeah. You're right. So that's the problem. Okay. Yeah, so that's the problem. So that's half. Is it?
No, I'm saying why do you need to?
No, okay, yeah. So okay, yeah.
That's 3/8.
Okay. So the problem is that this one goes now, right? We don't need to times half because it's coming there.
Yes.
Plus this needs times half, right? That equal
But 1/2 times 1/2 is 1/4. And 1/4 plus 1/4 is half. Yes, it's not 3/4. It's half.
Okay, with my math. Okay, this is half, and this is the same, right? So
Yeah.
that's 1. Okay, good job. On day 99, we talked about the number of ways from top left to the bottom right? We use the dynamic programming we talked about. We can solve that using top down and bottom up dynamic programming, remembering the results. Yeah. So ST. So let's say if we want to find out the number of ways passing this point, so how do we get it? From S to T, we're given this grid, and from top left to the bottom right, and each time one step to the right, one step to the south.
No, you say right. You say east and south, or you say right and down.
Okay, right and down. Okay.
Not one of each.
Okay, east and south. And we want to find out total number of ways passing this X from top left to the bottom right. We talked about previously this FRC equals FR minus 1C plus FRC minus 1, right? We know that, right? And we talk about probability. We want to find out the number of ways passing this point. How do we get it? We can decompose this problem into 2 smaller problems, which is... So in order to find out the number of ways passing through this point, how can we solve this problem? The number of ways from S to T passing through X. So we can solve this problem in 2 steps. First step is we find out the number of ways from S to X to X, and the second step is from
X to X.
and then
X to X.
and then the next step is
X to T.
okay. So we can get 2 functions, right? So first of all, we get the number of ways here, which is A. The number of ways here, which is B. Okay, so the answer is A times B. Okay, and previously this probability I said 50%, right? If it's not 50%, we can still do it, right? For example, if 60% going right, 40% going down, then we can adjust the value, and this is still 100%, okay? Okay, what have you learned today? What have you learned today?
Probability.
So what's your biggest takeaway today? Okay, let's put it this way. What have you learned? What's the biggest takeaway?
5 chicken nuggets that are large size.
What?
Take away.
Okay. Okay, Eric, what's the biggest takeaway?
Uh,
And a hamburger.
so
And
the
hamburger.
S
Yeah.
to the calculating S passing the X, and to calculate that is S to X and then X to T.
Okay, the times
Times
thing.
together.
Okay. So actually today's the topic is this one, probability, okay? But this is we have talked about this before, okay? The probability, yeah? on the border, you just, you're not splitting, right? Because when you are at the border, right, there's only one way, there's not two ways. When you are in the middle, you can split into two, that's 50% each, okay? Alright? And then you accumulate. This one, you can make a calculation, the bottom right must be 100%, okay? Okay, that's it for today, bye-bye! Bye-bye! Say bye-bye.